Alright, so we have a problem here. I'm just going to start drawing and I'll explain it as I go. It says a patient's elbow is flexed 90 degrees, so you should kind of think of this as the elbow. And then you have 2 inches here, the force going up there, and we'll just use meters. I think it shows inches on the board, but we'll just scale it up. And if you take your whole forearm about halfway through there, it's going to be about 6 inches, and again, we're going to keep the units the same, so we'll go 6 meters. And then the whole arm itself will make 14 meters. And something that's important here is you think of like a 25 pound dumbbell, but I mean you can't really do pounds, we're going to do newtons, so there's a difference there, but just imagine that's going to be a dumbbell, it's going to be force pulling down, and let's see what else is the same. The weight of the forearm is 4 newtons, so you think of this, then 4 newtons, you know, gravity going straight down, you know, just going down as well. Okay. So what it's saying is calculate the force, muscle force required to hold the weight in hand. So as we know, force, I'm sorry, take back a second. Torque equals force times distance. And so what we're going to need to do is it looks like we have 2 things. We have the weight of the forearm that's pulling down, and then we also have the weight of this dumbbell or whatever we're holding isometrically is also going to have us pull down. And because we're holding this isometrically, the sum of those 2, both the 4 newtons force pulling down and the 25 newtons pulling down, is going to be held up by this force right here that's going up. So that's going to be the same as both of those. So again, we can think of this as like torque 1, torque 2, and then again, so for force, we're working in newtons. So this will do, 1 is going to be 4, the other one's going to be 25, and we can times the distance. With this one it's 6 away, and this one is 14 away. Okay, so this one, 24 Newton meters, and this one would be 350 Newton meters. Alright, and so I mean you just usually add those up, you know, and you're looking at 374 Newton meters, and then so that gives you the total mass, or I'm sorry, the total amount of torque, the summation of torque of those 2 spots. And notice that what we're looking for, the problem said calculate the muscle force. So we're just looking for force, and again, force would be in newtons. So we need to figure out just how to get rid of this meters here. We don't need that. And so how we're going to do this is we're going to put this 374, we're going to divide that, and this is Newton meters, we're going to divide that by 2 meters, and then what we're going to do, oh, and the reason I set that up, you can kind of think, so for here, if you're making the same equation, you would already know the torque. Again, we found that out, so 374 Newton meters, and we know that it's you know that it's 2 meters, but we don't know the amount of force. And so that's where we got this. We divide this by 2 meters, 2 meters. Anyways, so sorry about that. So that's going to be 187 newtons. And so that's the first question. And let's see if I can scroll this down. I guess not. Anyways, so the next one we're going to do is we're going to try to figure out the mechanical advantage. So the biggest thing we're here looking at is we need to figure out the equation first of all. So I'll just do this down here. So mechanical advantage, you can have a big A there. Anyways, equals effort arm over resistance arm. So again, this isn't going to be too complicated. Effort arm is here, it's 2 meters. Resistance arm is 14 meters, which gives you 0.14. So that's your answer to the second question there. And then the last one, oh, I guess there's 2 more. So what type of lever is this? Because this is less than 1, we know that it's either going to be a first or a third lever. And the reason that we know that it's a third rather than first is notice that where the order is. So here we have kind of the fulcrum, then we have the resistance or the effort arm, and then we have the resistance arm or the moment arm. And so that's just when you look at the notes, that's what it says for a third class lever. On the contrary, if it's a first class, then you would have it looking either like this or like this, where the fulcrum is going to be in the middle of those two things. Alright, and then the last one is label the effort force, resistance force, effort arm, resistance arm, and force from gravity. Okay, so start at the top, label the effort force. Sorry, this is all over the place, but this is effort force, resistance force. So that's going to be, sorry, these are solid lines. Oh, sorry, made a mistake. That's the resistance force. This is force from gravity. Effort arm is right here. Resistance arm is going to be this whole thing. And then, yeah, so that's it. Hopefully this helps someone. I just got a lot of help from classmates and stuff, so I figured if there's anyone else that needed help with it, well, here it is. So, sounds good.